I'm going to be talking about running a Python package for Raspberry Pi. So my name's Ben. I work as a senior software engineer at the BBC in an innovation team within BBC News called BBC News Labs. I formerly worked as various things, but a community manager amongst other things at the Raspberry Pi Foundation in my previous employment. I'm based in the UK, and you can find me on my website, my Twitter, and GitHub. So get straight into this. So I'm talking about pip and distribution of Python packages. So package maintainers uploading releases to PyPI, the Python package index. So for packages implemented purely in Python, they should upload a wheel and a source distribution. So the wheel is the binary distribution, precompiled, in the case of pure Python, not compiled, but just zipped together into this transferable format. And for packages requiring compilation, so either implemented in C, C++, or various other things, they need to be built on every combination of Python version and operating system and system architecture that package wants to support. And they have to upload their build wheels of all of those things and upload them all to PyPI. So any users outside of this matrix, of whatever their matrix of support is, then they fall back to the source distribution and have to build it themselves, do the compilation steps themselves. That can sometimes be time-consuming and difficult. So just a very, very brief, simplified demonstration of how pip works. So if a user runs a command like this to install a specific version of a package, first of all, pip looks at the package's index and takes all of the files that are provided for that package. Then it starts to narrow it down based on first on the version that they specified. So 1.2.3, something like that. It gets all of the files that relate to that specific version. Then it filters those down based on the user's Python ABI, so which Python version they're using. Then it filters down based on their operating system and the system architecture. And then it's left with some number of files which match all of the criteria that they have, and those are the results that pip has to work with. And so it picks if there are more than one, it picks the best one and uses that as its install. So you end up in a situation, one of these two situations. So either you have a source distribution and a wheel matching all of your criteria, so your architecture, your operating system, and so on. And in that case, it picks the wheel because that's easier to work with. And or alternatively, if you didn't find a wheel matching your architecture or your system criteria, then you just have the source distribution. You have to build it yourself. So the third option, of course, is that they don't provide a source distribution and it didn't find any matching wheels, so you don't have anything to go on, so the installation fails. And of course, if you're left with the source distribution, that's the only thing you have. It can also fail if you haven't got the right libraries and developer tools and things required to make that compile work. So that can fail as well. And so this is the situation that Raspberry Pi users found themselves in. If there's no ARM wheel, which there generally isn't on PyPI, then they'd get the source distribution. Pip would start to try and build it, and then they'd have to start figuring out, which apt dependencies do I need to be able to successfully build this and get it to compile. Once they've got past all of that, the actual compilation can take a long time, especially on the first generation Raspberry Pi, which was just a single core. So that's where piwheels comes in. So this is an open source project maintained by myself and a guy called Dave Jones. This is tooling. The project automates the process of building ARM wheels of everything on PyPI. So every version of every package, and we target all models of Raspberry Pi, specifically targeting the Raspberry Pi operating system, the official operating system provided by Raspberry Pi. And we provide a pip-compatible index, which is using standards defined in PEP 503. And this can be used as an extra index alongside PyPI. So your pip commands go to both websites, and it has some additional files that it's able to use in its comparison about picking an appropriate file. So this is what our build matrix looks like. We build for each version of the Raspberry Pi OS, which is based on Debian, until each one goes end of life. So we used to support Jessie, which was Python 3, which had Python 3.4. We don't build for that anymore, but Stretch is still in support by Debian, so we still build for that. And we also build for Buster, which provides 3.7, and Bullseye 3.9. And we build Linux ARM v6 and ARM v7 wheels. So the piwheels website, piwheels.org. So this is similar in structure to PyPI. So it provides a simple index, which is what pip uses. So pip requests go to the simple index within piwheels or PyPI. And we also have project pages, which are sort of a human browsable index where you can actually look around the website and look at packages and see which ones we have, that kind of thing. And we also have some additional info pages, and there's a blog and things on there as well. We natively compile all wheels on real Raspberry Pi hardware. This is using a service provided by a hosting company called Mythic Beasts. And the stack that makes up piwheels is mostly built of Raspberry Pis. So the master, the main Pi, this hosts a website, serves all the wheel files, and it does all the monitoring of PyPI events, and it logs builds and logs downloads and puts everything in the database. Now, we used to have the database on that same Pi, but we got to a point quite quickly where it was running out of RAM, so we've moved that onto a VM now. This was before the Raspberry Pi 4 came out, which has more, bigger RAM options, but that's now running on a VM. So the database has all the information about all the packages and all the versions and all the build attempts and all that kind of thing. So from that, it generates what the build queue is. So, and then we have a series of Pis which do the building. So there's Pi 3s running Stretch and Pi 4s with Buster and Bullseye. And we can scale those up and down according to the build queue. So following PyPi's event log. So we follow this log, which in the beginning was quite a questionable source of truth. You see here for SciPy, this is some events, and you can see the events were logged out of order. The serial numbers, if you take them in by serial number, that things are happening out of order the way that they couldn't have possibly happened. Things were deleted before they were created and all that kind of thing. But after a while, it gets more stable, so you can kind of take that time period before what we consider the epoch of when PyPI logs were correct, and be able to take it from there and work out what actually happened. But yeah, as I say, it's more reliable now. So we can ignore most events that come through. So things like people updating the descriptions or the metadata on there, or the users and things like that related to packages. We can ignore most of that, but if we see a package that was created or deleted, or a new version added or deleted, or something like that, we can update the database with that piece of information, and then the queue gets formed out of that. And we can also request, it can request pages to be rewritten and updated or deleted as necessary. The way that the build queue works, so for each package version, for every single version of all the packages, we attempt to build it on the lowest currently active ABI. So in this case, it's Python 3.5. And then if that build is successful, it either yields a pure Python wheel, and in that case, we don't, if that comes out, we don't need to do anything else, so we can just quit there. If it produces a platform ABI, so one with an ABI tag, then we have to move that onto the next ABI and get that to build its own ABI wheel. Or it could, of course, it can also fail, in which case we do want to try it on the next ABI as well. And so on. We move on to the next ABI and keep trying until either we've got all of them done or we've built a pure Python wheel. So for users using piwheels, so Raspberry Pi OS is pre-configured to use piwheels.org as an additional index to PyPI. So users don't have to do anything. They don't have to know about it. We don't have to try and get the word to them. It just works, and it makes life easy for them without them having to do anything. So you can see here, pip install SciPy from a Raspberry Pi stock OS out the box. Pip install SciPy will go and grab a wheel from the SciPy wheel from piwheels and download that and use that. without them having to do anything. So so last year, throughout all of 2020, we served 16 million downloads from PyWheels, and so far this year we've already served nearly 30 million. And this is kind of pretty much doubling every year. We're seeing real growth every year, and this is all being served by a single Raspberry Pi in a data center in London. The way that we run the website is it's a static site build. So we write out the homepage and the basic single pages once, and then obviously the homepage gets updated periodically because it's got some statistics on it. But then everything else, so the package pages and the simple index and things, they just get changed when they just get rewritten when something changes. So so there's no software actually. There's software controlling builds, and that's a Python code base that's running 24/7, keeping up with all the builds and everything. But there's no actually application running the website. It's all just static pages. So yeah, whenever something changes, we rewrite those little bits of it, and that's how we kind of maintain it. So every hit to the website, whether it's downloading a wheel or accessing a simple index or hitting a project page, it's all just hitting static pages which have been generated. So this is what the simple index looks like. So this is the page for SciPy. So this is exactly the same as what you would get on PyPI. So pip goes to this page and uses that to determine what files are available. Here we've just got a load of Linux ARM wheels that we've built for SciPy. And this is what the human readable project page looks like. So you can browse this page and actually, take in, okay, they've got these versions, and this is how you install it, and there's links to the PyPI version and that kind of thing. And you might see here, so this bit here shows the installation instructions. So this includes any Debian packages that you'll need to install. So the apt install is those are the prerequisites that are required to get this library to start to work. Because without that, you get into problems like this. So you get something like it says a shared object file can't be found, and it's a nightmare to have to work out what it is that you need to do to resolve this issue. It's really unintuitive. So providing those apt dependencies on the page just makes it much easier. It just means you just have this, copy paste this thing in, and it will install everything you need for that package. The way we do that is I actually wrote a blog post a few years ago, how to work out the missing dependencies for a Python package, and this blog post has had more hits to it than anything else I've written on the PyWheels blog, and it's still getting hits every day at the moment. And it's basically a case of running LDD on the shared object files that are in the disk directory of where the package is installed into, running apt file to search for any libraries that were not found, and that will tell you, oh, this package provides that shared object file that you need, and then you install those packages. So what we do is kind of automate this process. After having built a wheel, we run this process to determine which apt packages provide the necessary library the package needs, and then we put that on the project page, so it makes it nice and easy for people. And then with that, you can just install you can import the library, no problem, once you've installed those dependencies. We also have a JSON API, so you can find you can get information about the packages and the files that we have via this API, as well as some per package download stats as well. And finally, down the bottom of the packages project page, we have these buttons. So you can hit the search button, and it will show you any issues that are currently active that are related to that issue, to that package. And or you can click one of these buttons to open up a new issue, and that will open up a GitHub issue form with all of the fields that it can already filled out. And that means people are able to register with us that, oh, there's a package missing, or there was a problem with this package, give us the details, tell us which Python version it affects, that kind of thing. And that allows us to manage the issues with any packages, and we can take a look into why a package is missing and see if we can resolve it, that kind of thing. So that was a really quick kind of rundown as to what it takes to run a Python package index, and in this particular case for a specific platform. So there's lots of things we can do that make it it's much easier for us because we're targeting a very specific combination. So we're taking specific hardware, specific architecture, specific operating system, but it is the one that is recommended people use. So we get away with a lot by doing that. We don't make any additional promises that we will support Ubuntu, for instance. You would have to, you would have different app dependencies if you ran it on Ubuntu, and there would be different Python versions, that kind of thing. So we're able to achieve quite a lot by doing that. But there, like I said, there is a lot that you run into that is difficult to maintain in terms of following PyPI and the discrepancies and things like that. So there's lots and lots going on that you have to be aware of, and of course managing people's issues if they find packages missing and things like that. So that's all from me, and I think there's plenty of time left for questions.
Hi. Thank you very much. That was a great talk. We do have a question. Let me copy it here so we can show. The question is, does that mean that you can pump up optimization specific for RPy when you're building the wheels?
We generally don't, because we build on Pi 3s and 4s, which are the ARM v7 instruction set, but we build them for the mic's off. But we build them for but the Raspberry Pi OS is a 32-bit operating system, and it runs in ARM v6 mode. So the SD cards are compatible if you switch from a Pi 3 to a Pi 1, for instance, or a Pi 0 to a Pi 4, whatever, it will still work. And so people generally have an expectation that kind of thing will work. And if they want to do something more specific that is optimized for a specific ARM version, then they generally do that and go out of their way to do that. The operating system itself just works across all Pis, and people kind of expect that's the case. So we don't want to it would cause a lot of confusion if we didn't do that, unfortunately. So, however, there's a couple of exceptions. So things like TensorFlow, there's no source distribution of TensorFlow on PyPI. They don't generally support people building it themselves. They just provide wheels. And so we approached them a few years ago and said, would you be able to build wheels for the Raspberry Pi, and we can host them for you, so that we don't have people don't have to try and do it through these unofficial back routes and things. And they start providing wheels to us, but they were because they were compiled especially for the different architectures, they were optimized for accordingly. So the same for OpenCV, but we used to build those offline, and they were different between the two. But yeah, so generally not. But yeah, I can see why a lot of people would want that. But yeah,
cool. Thank you. We have another question. How do you relate to Python packages packaged for Debian like Python 3-foo? Do you ignore them or not use them?
So it's up to the user, really. So if Python 3 foo in Debian Buster is version 1.2.3, it's stable, and that's the one Debian provide, and you're getting it from Debian. And if that version is okay for you, you can use it, and it will work the rest of your system. That's fine. So for instance, like the NumPy that comes with Debian, it's fixed into that version whenever that Debian version is released. Debian is released every 2 years, so you're stuck with that version of NumPy or whatever for 2 years. That's fine if you want to stay on that version. It's compatible with the rest of the OS. If you want a newer version, which people obviously invariably do, you get it from pip, and so we're providing all of the versions as soon as they're released. We build them and they're available. So the same way you would on your PC or something, you would pip install and you would get the latest version generally. But if people just want to use system stuff, that's fine.
Cool. We have another question. You said that APT packages are published on the project pages. I wonder if it would be reasonable to provide a bindep.txt compatible file. Ideas?
Yeah, it's a good idea in principle. It would be good if there was a standard way of telling people which packages they need. It's usually a case of a package will have something like PIL imaging library. If you go and try it, if it says if you want to install this yourself or build from source, you'll need to on Linux you'll need to apt install this, and this. There isn't a sort of a standard way. There'll be somewhere they've documented it, or somewhere on some GitHub issue somebody will have said this is what fixed it for me. So it would be good if there was a standard, but it's a little bit more complex because like I said, we build on a specific version of the Raspberry Pi OS based on Debian with the packages that archive provides. And so if it was built against GCC or GStream or whatever it is, whatever libraries it is, we can only really promise that it works with that exact version. So if you apt install the version that provides that same shared object, then it will work. Problem is if you're talking about this for Linux, then it's not just apt, it's DNF and Yum and everything else. Even if it is apt, then you've got different versions of Ubuntu and Debian, and they all provide different combinations of all of those libraries and things. It does get really complicated, and it might just work in certain circumstances, but you can't really guarantee it. It's quite hard. Like I said, in PyWheels, we just focus on one thing, and we know that it works giving these exact instructions because we built it on that same operating system with those same libraries. So that's all that's why we can guarantee it. It's more difficult to solve the general case. The alternative is that you bundle your dependencies in the wheel, which we don't do. Maintainers can do that, and they generally tend to for things like Arch64. They'll bundle the dependencies in the wheel, but that means your wheel contains an old, outdated version of something forever. And if there's a security problem with that version of GCC or whatever it is, then there's no way of updating that because it's tied and it's bound to the wheel. So we distinctly do it differently, so that's not the case. And also, you install GCC once, and you don't have a copy of it for every Python package you install, that kind of thing.
Cool. Yeah, there is another comment about bindep projects coming from the OpenStack community, and yeah, but.
Okay, I wasn't sure if that was the name of a real project or just somebody proposing a new standard in the comments, but that's something I'll look into. So it allows you to list level packages there. Yeah, I'll take a look at that. Something I'm not familiar with. Cool.
So, thank you very much, Ben. We'll have a 5-minute break now, and we'll restart at 5 minutes. So,
thank you.
Bye-bye.